Hello everyone. Today we'll be discussing how we can automate a smart classroom for our university. This is a part for our computer network lab project. So we are discussing how we can perform or design a smart classroom for our university so that the students can be facilitated as well as the faculties. Let's go on to the design. Firstly, we'll discuss the devices, then the conditions of automations, and then we'll see some real world simulation based on the real life conditions are like temperature, humidity, and something. Okay, let's get on to it. Firstly, for our devices, we are, of course, a smart classroom will have internet. So we have used a Wi-Fi router. This is the home router and the primary router named. So this will be simulation for the internet. And there's a classroom PC. We have used it one dummy PC, but there can be multiple PCs present in one classroom. And these can all be connected using a Wi-Fi network. The dashed line between the networks or the devices mean they are connected wirelessly. If they will be connected wired, then there will be a straight black line or straight wire colored line. So this goes on to the collection. Let's go on and see PC wireless and see that we have successfully connected to the access point. Here the access point is the Wi-Fi router present, and the Wi-Fi range is frequency is 2.4 gigahertz. So this is why it is showing. Let's get on to the devices. Firstly, where as for automation works, there will be IoT devices. So I have added a lot of IoT devices to simulate a classroom. But firstly, let's talk about the home gateway. Home gateway acts as the central server or the hub for IoT controlling. So we have firstly added a home gateway, and then we have added the IoT devices. There are lights, three lights, but one of them we are using as a dummy projector, as there is no projector and device. There is a teacher's tablet. The tablet that will be supplied to the faculty, and then there is a smartphone controller. We can see there is a AC, there is a fire alarm, a motion detector, a smart door which is automated, a humidity sensor, a temperature sensor, and there is a smoke sensor along with an alarm. These old cars are added to simulate smoke. We will discuss it further on in the video. So this goes on the devices section. Now let's go on to the automation condition. So we know that in the classroom there is always a remote present to control the AC when there is AC present too. So we have used a smartphone as the IoT remote or controller for our classroom. So let's go on to it. The desktop, then IoT monitor. There's a hang time for IoT monitor, so we have to wait a bit. So here we can see all of the devices. But now we will not control the devices used on this remote. We will implement the automation conditions. Let's go on to the conditions. Here we will see that there are many conditions, but I will break them down one by one. So if the humidity is high, we have turned on the fans to be on and in high status here. Again, if the temperature is high also, despite the humidity being low, then the fans will be turned on and set to high state. If the humidity is less than 50% or the humidity is lower, then we can turn off the fans. This goes on for our fan controlling or environmental conditions. If there is a smoke sensed, like a fire is getting on or there is too much smoke between the candles or there is an incident of fire somehow, so the smoke sensor level will increase gradually, and then the smoke sense rule will be triggered. What will it do? It will turn on the alarm and the door will be unlocked. So the students can safely evacuate the classroom. Now, if there is smoke sensed and there is a motion, then all the electric appliances will be turned off, the lights and fans, also the AC. And if there is a fire alarm, there's another siren named fire alarm. If the fire alarm is pressed by a student or the fire alarm is turned on, then the door will be again unlocked and the alarm will be turned on so that the evacuation will be in order. That goes on for our emergency conditions. Now let's say the smart campus is usually under the CCTV surveillance, and these CCTV surveillance lack or are weak in night vision again, unless they are very high priced or expensive. So we have calculated or automated a rule. So if that the motion sensor detects any motion, then a light will be turned on so that the student or faculty or any intruder after hours can be detected easily. Now the access control. Let's say a faculty wants to start the class. So we have simulated a button like accessory at the window that we will see named teacher's desk. So if the teacher's desk is turned on or the button start class button is pressed, then all the electric appliances related to teaching will be turned on like lights, AC and projector. Also the door will be locked so that no more students can enter or no more any outer party cannot enter and interrupt the class. Again, after ending the class, the teacher can turn off this desk or the dummy button, and then the electronic appliances will be turned off. Notice that we have remained the control of fan to the environmental sensors to maintain environmental quality for all the time for faculties and students. So this goes on for our conditions. Now let's say them in action. Okay. So firstly, we can see that the humidity sensor is showing more than 70%. This matches with the condition. So that now the fans are turned on and they are in high state. The two lines mean high state. If they are off, there will be no lines, and they were in low state, then there will be one lines. So the two lines indicate high state. Now we will build up smoke and test the smoke sensor too. So let us now turn on smoke for now. We have used old car for this smoke simulation. Now the temperature is 20 degrees Celsius, so the temperature is not high enough for the fans to turn low on, but the humidity is high enough, so the fans are turned on now. The smoke is building up. We will see that in a little bit. Now the projector, there is a dummy projector. Okay, now let's say the smoke is building up. We can see the value here. It is 36%. When it will be 50%, then the alarm will be turned on. Let's see. We can simulate and increase the time. Now let's refresh. Okay, we can add another car. We increase the time. Now let's see how the smoke value is faring. Here the value crossed 50% and then the alarm was sounded. Now the door is now unlocked. How can we say that? See, there is a green color on the door. So the door is now unlocked and there is also uh, uh, alarm present. So the evacuation can be in order. So this condition checks out. Again, uh, we said there's a motion detector and there's a light. We will test that later. For now, we can turn off the cars for now and let's check if the value is now, yeah, the value is now falling. Yeah, the value is now falling. Okay, so this marks our successful implementation. Now let's see how the motion detector fares. Let's see, let's turn on the motion detector. Okay, see, the motion detector is turned on, and if we move the laptop, see, the light is buzzing. So this is indicating the motion detector is working successfully and a motion is detected as well as the light is turning on. So this will act as an alarm for the motion detector. Okay, so this also marks our successful implementation. Now let's build up smoke. Okay, we will know why. So for the access control, there is a teacher's tablet present. So let's go and let's say the faculty has entered and he or she will now start the class. So we'll go to IoT monitor. Let's wait a bit. Yes, the IoT monitor is logged in. And let's say the teacher will now start class. We say the teacher's desk is the dummy button for starting class. So let's turn it on. See, the light is turned on, the projector light is turned on, and uh, the AC, the red LED is also turned on, which means that everything is working successfully. Let's say the teacher will now end the class. So we turn this off. See, all the electronics are already turned off. The AC is also turned off, and the lights are also turned off. This marks the successful implementation of our classroom project. We hope you understand everything, and if you have any queries, please let me know in the comments. Thank you.